All right. Key features of linear functions and exponential as we begin our dive into dealing with quadratic functions this semester. And, yeah, it's a Tuesday. There's my intro. Key features of a linear function. The slope of a line is the way we measure the steepness of a line. It's a way to measure the steepness of a line. You've got to remember, like this line that we're talking about here, it's rise over run. So the slope of this line here, I want to start at a point where it crosses nicely on my grid. How far do I rise and how far do I run to be back on my line? In this case, I rise 2, I run 1, so my slope is 2 over 1. That's a horrible looking 2. We'll make that a little bit better. I don't know if that's better or not. Okay? Moving downward, the x-intercept is where the line crosses the x-axis. This is also where the y value, and I'm saying it, I don't know if you can see that or not, but the y value equals 0. So for this particular graph, it is negative 1/2 and 0. Okay, that's where my x-intercept is. My y-intercept crosses the y-axis, hence the y-intercept. This is also where the x value is equal to 0. So the y-intercept here is, and I'm just going to write it down here, 0 and positive 1. Right? And x-intercepts and y-intercepts are true in quadratic functions as well. I don't believe there are x-intercepts in a exponential function. So the other thing we look back is when we look at this line, we see, oh, from left to right, it's increasing. So therefore, y equals mx plus b. M is my slope. B is my y-intercept. And for this particular equation, y equals 2x, or 2 is my constant rate of change, plus 1 is my y-intercept. And there is your key features from linear functions. Key features of exponential functions. This one's a little bit more involved. I don't know why we get so involved because we don't talk about these but briefly. But this dashed line down here, ASYM, asymptote, asymptote. That is how you say that. It is called an asymptote. Okay? An asymptote. I'm going to change the verbiage up here a little bit just by putting an N. An invisible. It is an invisible line that the graph gets closer and closer to but never touches. Never touches. Okay? It never touches. The equation of this asymptote is going to be y equals 0 because it is a horizontal line. If I set something on it, it does not roll anywhere. That dashed line has a 0 slope. The next thing we're going to look at is the domain and range, or the function value for this. Now the function value is the domain and the range. The domain is x values, the range is y values. So how do we think of this? Well, here's how I try and think of this. When you're finding the domain, you only are concerned with x values. This particular graph does this. I think the arrow is right there. Okay? So I want to block out the y-axis if I'm looking at my domain. In this particular case, where does it start from the left and where does it end on the right? In this particular case, the arrow indicates infinity, so it starts at negative infinity. And where does it stop? As the graph continues to move to the right, it continues up. But as it continues up, it also continues to the right, and it goes to positive infinity. So this graph is not limited on any x restriction. There is no restriction xy's. The range is from the bottom to the top. Now when I talk about y values, I want to ignore the x's and only talk about the y values from the bottom to the top. Now because this graph continues down, as it goes to the left, it will always continue to go down. How do I know it will always continue? Because it has an arrow. So negative infinity means it will always continue down. Okay? And that will go to where? As it continues up, it will always go up. So that continues to positive infinity. Right? If you get stuck on that, let me know. I'll explain it again because I'm sure there's a lot of other people that are going to say, this one stinks because it's not limited. Right? Now we get to this guy right here. This guy right here, we're talking about growth and decay. A exponential function will either grow or it will decay. Here's where you need to change things a little bit. Come on, work with me here. You need to include growth is when. Growth is when the function is increasing from left to right. When the function decreases, it is considered decay. Okay? So growth and decay. And then we also have a y-intercept where the function crosses the y-axis, just like in our linear function. This is also called the value of a, or the a value in the equation. Now when we get down here to the bottom, we have the a value and we have the b value. So here's what happens. A is the initial amount, So A would be the initial amount. It's also the y-intercept of the graph. So it's the initial amount plus it's the y-intercept. And a little bit of verbiage change here. Cross off the equals, the 1 and the plus. It's just B is the growth rate. Okay? B is the growth rate. So if it's positive, it's growth. If it's negative, it's decay. And that's right here. When B is less than 1, it's decay. Okay? When it's greater than 1, it's growth. Right? So there's your key features of exponential functions. Now, we didn't talk about key features of quadratics because we haven't talked about quadratics yet. So we're going to talk about what those key features are. But understand, a quadratic function will have an x-intercept. It will have y-intercepts. Okay? Notice on the exponential there is no x-intercept. Okay? That's because it gets as close as it can, but it never touches the x-axis. A little bit mind-boggling in that aspect. Now I'm going to talk about the explicit and recursive. So I'm kind of bundling things together here. So stick with me, and I'm gonna kind of pound through this. What is an explicit equation? It's an equation that can be used to take any term. Okay, we can calculate by plugging any term in and simplifying. That is an explicit equation. I'm going to talk about the recursives first, and there's a reason why. Okay? A recursive equation is an equation that shows how to calculate the value of the next term based on the previous term. So I need to know something to calculate. So which type of function is the first one here? The first one is a linear function. And how do I know that? Well, I've done this 5 times already. 1 is how I know. But how do I know it's linear? Because based on my output values, negative 2 to positive 2 is plus 4. 2 to 6 is plus 4. 6 to 10 is plus 4. 10 to 14 is plus 4. So I know this because it has a constant rate of change. Okay? Constant rate of change of 4. And you need to start thinking about patterns. So recursively, here's how I create my recursive equation. the f of 1 equals the f of x equals f of x minus 1. That's all standard in a recursive equation. So f of 1 equals, and f of x equals f of x minus 1. All of that will appear in every single recursive equation you write. Okay? The first term, what is the first term? We'll go back in the table and see what is the first term. The first term is 10. So f of 1 is 10. And what do I do here? It tells me f of x minus 1, which, by the way, that just means the previous term. I'm going to take the previous term and I'm going to apply the common difference, plus 4. There is my recursive equation. It's done. Okay? It's that simple. Number 2, what type of function is this? Well, what is happening? Maybe I need to figure out what's happening before I determine the function. 1/3 to 1, multiply by 3. 1 to 3, multiply by 3, multiply by 3, multiply by 3. You should see that it is a multiple of 3. It has a common ratio. This is how I know what type of function it is. Notice it's multiply, common ratio, not consistently adding. So this is a exponential function. Exponential functions have a common ratio. How do I write a recursive function for an exponential equation? Well, remember, this part right here is consistent. F of 1 equals f of x equals f of x minus 1. That is the same. It's the same as it was over here. But what changes? Well, gee, maybe the value of the first term changes. F of 1 is 9. Yes, so instead of f of 1 being 10, f of 1 is 9. Now, what does it want me to do? It wants me to take, again, the previous term and do what with it? Multiply it by the common ratio. There, you're done. Now, how about the last one over here? Well, gee, this one has to be quadratic because we haven't talked about that yet. How is it quadratic? Well, it's quadratic because of why? Well, look at my output value. What do I do to 12 to get to 7? Okay? 12 to 7 is minus 5, not plus 5, sorry. Minus 5. 7 to 4, minus 3. 4 to 3, minus 1. 3 to 4, plus 1. Okay? That is what we call a first difference. Not the same. Second difference. Can I do a second difference? What do I do to minus 3 to get to minus 5 to get to minus 3? Plus 2. Minus 3 to 1, plus 2. Minus 1 to plus 1, plus 2. I know that it is a quadratic because it has a common second difference. That is how it's quadratic. So now how do we create our equation? Well, again, f of 1, g, that's the same. I've got to know what my first term is, and that f of x is equal to f of x minus 1 is, again, that's always constant. So what is f of 1? F of 1 is 3. And then it says, hey, apply the common second difference. So plus, what was it? What was it again? Go back up and see. It was 2 x plus what you do to get back to the y-intercept. Well, what's the y-intercept? The y-intercept is where x is 0. So right here is my y-intercept. What did I do to get back to that? To get back to that, I subtracted 3. So minus 3. There's your recursive equation. Now we're going to talk explicits here. Okay? How about explicit? Hang in there, we're almost done. We got 3 more to do. Okay? This one is linear. This is hard because most people don't see that it's adding 1 to each arm every time. So the very first one has 5. The very second one is going to have plus 4, which is 9. The third one is going to have plus 4, which 9 plus 4 is 13. Okay? So it's linear because, again, constant rate of change. Okay? Which is plus 4, plus 4, plus 4. So now, how is it having me write an explicit equation? The explicit equation is a little bit simpler to write, a little bit more complex to come up with, but a little simpler to write. Now, instead of the first term, you're going to put the starting value. So the starting value up here is going to be what? F of 1 is 5, that's its starting output value, plus the common difference, which in this case is 4 times x minus 1. There is your... Now, wait a second. Some of you are like, hey, that's supposed to look like y equals mx plus b. If you distribute, you get f of x is equal to 5x plus 4x minus 4, and you get 4x plus 1. There's your y equals mx plus b. Same equation, just written in a different form. It's going to take me a little bit to get used to that too. Okay? Second one, common ratio. What's happening here? This one is exponential. And how do I see that? I see 5 groups right here. And what's happening to the 5 groups from the first to the second? They double. Times 2. How about when I get to the third figure? Hey, they doubled again. Okay? So 5 groups, they double every time. I know this because common ratio is 2. They keep doubling every single time. So how do I create my explicit equation? I take the starting value, which what's the starting value? F of 1 is 5, and I multiply that by the, what does it tell me? Common ratio. So in this case, the common ratio is 2 to the x minus 1 power. There's your f of x. Okay, there's your explicit equation. We'll dive a lot more into that later. And then lastly here, what's happening with this function? You have to look at it. This function is quadratic. Why? Look at the center section here. The center section is 1 by 1, 2 by 2, 3 by 3, and I keep adding 4. Okay? So 1 by 1 plus 4. 2 by 2 plus 4. That actually will help me with my explicit equation. Okay? So how do I know that this is a quadratic function? Okay? This figure is growing in 2 dimensions. Okay? Don't know if I hyphenated that right or not, but again, this is an English class. So how do I write an explicit equation? Well, f of x is equal to my length, which is n, times my width, which is n, plus 4, or n squared plus 4. Okay? Again, it's just seeing patterns. So there you go for that information. And ask questions as you need to. Please do. Make it easy.